This is section 2.2, and this will be the first video in that section. And today we are talking about quadratic functions. So we're going to be recognizing characteristics of parabolas today and graphing them. Remember, quadratic function is a fancy way to say it's a parabola. A quadratic function is a parabola. So objectives 1 and 2, recognizing the characteristics and graphing it. Now, we want to work with our quadratics in standard form, and I showed you on the board here what standard form is. Oftentimes you'll hear it called graphing form as well. Just to review a little bit, hopefully you remember that the A value is going to be our stretch or our compression. The stretch is going to be if A is bigger than 1. And if it's between 0 and 1, that's our compression. Also remember, if A is negative, it's going to flip your quadratic upside down. The other thing to remember is that the vertex of the parabola, since it's normally at 0, 0, and we know that H shifts us left and right and K moves us up and down, the vertex of our parabola is going to be at the point H, comma K. So, in order to graph parabolas, we're going to follow a 5-step process. The first thing we're going to do is decide, is the graph opening up or is the graph opening down? After that, we're going to determine the vertex. Once we've found the vertex, we're going to find the x-intercepts. Now, this is going to help us deal with the stretch and compression. So this is going to help take care of the stretch and compression. We'll decide the y-intercept just as another point. And finally, we'll plot those points and sketch our parabola. So let's try an example. We're going to graph that given function. So the first question we have to answer is, does this parabola open up or open down? Since there's a negative here in the front, we know the parabola is going to open down. In order to determine our vertex, we're going to use the H and the K. Now remember, since in the equation it's -3, it's going to change our vertex to be at +3 because it's going to move it to the right. So we're going to have 3, 8 there for our vertex. Now we need to find the x-intercepts. Remember, to find x-intercepts, you make y 0 and you solve for x. So, if I want to solve this equation for x, I'm going to start by subtracting an 8 from both sides. Now, a common mistake here in the next part would be to square root both sides, but before I can do that, I need to divide by -2. Right now I have x minus 3 squared equals 4. Now we can square root both sides. Remember, when you do that, we get x minus 3 equals, we have to remember that there's 2 solutions to the square root of 4, in this case, positive and -2. The last step will be to add 3 to both sides. Positive 2 plus 3 is 5. Negative 2 plus 3 is 1. So our two x-intercepts are at 5 and 1. To find the y-intercept, we're going to make x 0 and solve for y. So we'll have -2 times 0 minus 3 squared plus 8. -2 times -3 squared plus 8. We have to follow the order of operations here, so we're going to do our squaring first, and we get 9 inside the parentheses. Now the multiplying, so we get -18 plus 8, and we can see our y-intercept here is at -10. Now that I have all that information, we're going to go ahead and put it all onto the graph. So we'll start with the vertex. I'm going to go over 3 and up 8. Our x-intercepts are at 1 and 5. Our y-intercept is way down here at -10. Now, the nice thing we know about parabolas is down the vertex, we get this line of symmetry. We know that parabolas are symmetric over the vertex. In this case, that line would be written as x equals 3, the line of symmetry. Since this is going to be symmetric, I can take this point down here, the -10, the y-intercept, and I can go flip that over that line of symmetry, and I actually get one more nice point here. And now I have 5 points. I'm going to connect them and sketch my parabola. And there's a nice sketch of the parabola. If we look at this next function, f of x equals x squared plus 6x plus 3, we can't graph this as easily because it's not in graphing form. So now we have to think about what we can do when a function isn't in graphing form. We want to rewrite it to be in graphing form. In order to do that, we need to review a topic called completing the square from Algebra 2. I'm going to start with just building x squared plus 6x plus 3 with algebra tiles. So we're going to have an x squared, 6x's, and 3 1s. Now, I'm going to take all these pieces and try to arrange them in a square. I'm going to leave that x squared in the top corner, and I'm going to take 3 x's and put them along the bottom here. And I'm going to take 3 x's and turn them and put them on the side. Now, you'll notice when I start filling in with these 3 1s that I don't have enough pieces to fill the entire square. I'm short. I need 6 more 1s if I want to build that square. I don't have those. I need 6 more. Now, if we just look for a second, the dimensions of this square would be x plus 3 by x plus 3. If I wanted to write that, it would be x plus 3 squared. The problem is I didn't have enough pieces to build x plus 3 squared. I had to borrow some. I had to borrow 6 pieces in order to finish that square. So I'm going to take the x plus 3 squared, and I'm actually going to subtract those 6 that I borrowed. Now my equation is in graphing form, and I could go ahead and use the same process as earlier to graph it. Before we practice graphing some more, though, let's do a couple more complete the squares. So let's take a look at the next one, x squared minus 4x plus 12. Now, we don't want to have to pull out our algebra tiles every time we do this, so let's try to see if we can come up with a way to do this generically, using a picture instead. We know our rectangle is going to end up kind of in 4 pieces here. We're going to take the x squared and we're going to put it in that top corner. Now we have our negative 4x's. They're going to get split in half, and half are going to go on each side. Just like in our previous example, with our 6x's, 3 of them went on each side. So we'll do that over here. Now, in this case, it's negative 4. It's not going to change much. We're just going to say that it's negative 2 x's on each side. And here's where we need to think about the bottom corner. Now, before I do that, let's go ahead and just see what the outsides would be. The outsides would be x minus 2 by x minus 2. Now, if I multiply in the bottom corner, it should be, I need to have 4 ones. -2 times -2. If I look at my equation, I have 12 ones. I need 4 to build that. I have 12. I have plenty. In this case, I don't need to borrow any. I have some extra. The extra I have are 8 ones. So we have more than enough to build this. When I go to my equation, we had x minus 2 squared. We had enough to build that square. And then we had extra, so we're going to add on the 8 extra that we had left over. And we've now rewritten this equation in graphing form. Let's take a look at another one. This one looks a little different because there's a -2 in front of the x squared. Before I do anything, I'm going to go ahead and factor that -2 out in front. I want the x squared to be alone. So we're going to get x squared plus 6x minus 2 when we factor. Now that we've done that, we're going to go ahead and we want to cover up that -2 for a little bit. We're going to pretend like it's not there. And we're going to go ahead and complete the square as we normally would. Pause your video right now and see if you can work through the process on this one. See if you can complete the square. In this case, when we built our square, we needed 9 ones in the bottom corner. And we had -2 from our equation. In order to go from -2 to 9 that I need, we're going to have to borrow some tiles here. We're going to have to borrow 11 ones in order to make this square happen. So when I write my answer, we're going to have x plus 3 squared. And since I had to borrow 11, I'm going to have to take 11 away from this square because I didn't have enough to make that square. I have to take away the 11 I borrowed. Now let's go back up where we had this box. We still had -2 out in front. I'm going to put a big brackets here. Remember, that's just like a big parentheses. And we're going to write the -2 in front because now we need to put that -2 back in. The last step here is pretty simple. We just have to distribute the -2 to our two pieces. When I do that, I get -2 times the x plus 3 squared plus 22. This would be my final equation in graphing form. What I'd like you to do right now is try this example. And when you're done, I want you to bring it to class tomorrow. So the first thing you have to do is take your equation and you'll have to complete the square. Now, I'm going to give you a quick hint as to where to start. On this one, we have a negative out in front. It's kind of like that -2 in the previous question, but instead it's just a -1. So you should factor that negative out in front, and you're going to have x squared plus 2x minus 1. Now, go ahead and go through the process of completing the square, and then I want you to put all the points together and go ahead and graph this. And we'll start this in class tomorrow.